Before we start, let me briefly introduce myself. Michal already introduced me. Just a few words about me. I work as a principal front-end engineer at a company called Swiss Marketplace Group. In addition to that, I'm a core member of NgRx and Analog.js teams. And I'm also a Google developer expert in Angular. You can find me on Twitter if you use it by searching for my handle at Marko STDev. NgRx SignalStore, the SignalStore API itself is a part of the library called NgRx Signals. NgRx Signals is a standalone library. Standalone means that it does not depend on any other library, so it does not depend on NgRx Store, NgRx Effects, ComponentStore, or any other library. And it provides a reactive state management solution, and also it provides a set of utilities for Angular signals. Let's now see the overview, the APIs that NgRx Signals package exposes. So the first one, the most popular one, obviously, is the SignalStore. In addition to SignalStore, we also have some helper functions. They are called base features, and they are used to add state, computed properties, methods, or lifecycle hooks to the SignalStore. So they are called with state, with computed, with methods, and with hooks. In addition to these APIs, we also have a SignalStore feature function, and this function is used to create the custom features by combining base features or other custom features. We will see that later. In addition to SignalStore, there is also a function called SignalState, and SignalState is a lightweight version of SignalStore. In addition to SignalState, there is also a patchState function, and you can guess based on the name, right? By using patchState function, we can update the state of the SignalStore, but we can also use it to update the state of the SignalState as well. In addition to these core APIs, there are also two plugins. Two, at least for now. Maybe we will introduce some additional plugins in the version 18, we will see. The first one is RxJS interop. And here we have the Rx method function. Rx method is used for performing asynchronous side effects by taking advantage of RxJS APIs and operators. And also there is an entities plugin, and the entities plugin is, if you use the NgRx entity, this is the NgRx entity for the SignalStore. So it contains the with entities feature, and there are also some updaters, add entity, update entity, set, remove, etc. Okay, let's now talk about our main topic for today, about SignalStore. SignalStore is a fully featured state management solution, and it provides a native support for Angular signals and offers a robust way to manage the application state. This is by definition. It's built with some key principles in mind. So we try to create simple and intuitive APIs with SignalStore. SignalStore is also lightweight and performant. So depending on used APIs from the NgRx Signals package, the participation of the NgRx Signals package in the final bundle can vary between 0.3 or 4 to 2 kilobytes. So it's really lightweight. By using SignalStore, we can define our state management logic in a declarative manner. SignalStore is also modular, extensible, and scalable. So we are able to define building blocks that can be used independently, but also combined together for extensible and scalable implementations. And we also try to find some kind of sweet spot between opinionated design and flexibility. So with SignalStore, we try to, through the APIs, to provide some guidance on how state management logic should be defined, but in the same time, we try to provide flexible and customizable APIs. And yeah, SignalStore is also type safe. Of course, it's made with TypeScript, but in addition to that, it has some additional type checks that can help us to prevent potential bugs in the early phase at compile time instead of runtime. Let's now see how we can create a SignalStore. So to create a SignalStore, we can use a function that has the same name. And this function can be imported from the NgRx Signals package. This function, as a result, returns a dynamic service. And we called it here books store. like injectable. As an input argument, it accepts a sequence of SignalStore feature. And by combining SignalStore features, we're actually building our store. The most important one probably, base feature is called with_state, and we use with_state feature to add a state to our SignalStore. So in this case, we pass the initial state as an input argument, and if we want, we can also pass the input generic argument to ensure strong typing. The second base feature is called with_computed, and we can use with_computed to add computed signals to our SignalStore. Unlike with_state that accepts an object, an initial state as an input argument, with_computed accepts a factory function as input. Input of this factory function will be all previously defined state slices. So under the hood, SignalStore will generate signals for each state slice that we define here. And these signals will be available here in the next step as an input argument of the with_computed factory function. As a result of this function, we need to return a dictionary of computed signals. So here I returned 2 computed signals, total books and free books. You can see that they are created in the same way as any other computed signal by using the computed function from the Angular core package. Third base feature is called with methods, and based on the name you can guess that we use with methods in order to add methods to the SignalStore. As an input argument, it also accepts, similar to with_computed, it accepts a factory function, and input of this factory will be all previously generated, all previously created state signals as well as computed signals. So for instance, we can create addBook method. In this method, we want to update the state of our SignalStore, and to update the state, we are using a patchState function. This function accepts a store instance as a first, and the sequence of partial states or partial state updaters, we will see that later, as REST arguments. And we will also see why patchState function can accept multiple updaters. What's the benefit? So, as I told you, as a result, the SignalStore function will return injectable service, right? So, what we can do here, we can provide this bookstore, where needed. We can provide it at a component level. For instance, if we want to manage the local state, the component state, the next step would be to inject the store itself, and then it can be used in a component as any other service. So here you can see we're using state signals, computed signals, as well as methods in the template from the SignalStore. The next topic for today are lifecycle hooks in the SignalStore. So this is the same example that we just saw for the bookstore, and if we want to add lifecycle hooks, we can use the last base feature that SignalStore provides. Is called with hooks. By using with hooks, we can execute some logic when our store is initialized or when it is destroyed. It actually has 2 signatures. This is one of the signatures that is similar to with methods and with computed. So it accepts a factory function, and input of this factory will be all previously generated state signals, computed signals that we created, and methods that we also defined. And then as a result here, we can return what should be executed when our SignalStore is initialized, what should be executed when it is destroyed, or of course both methods are optional. So if we need some specific logic only on init, of course we need to return only the onInit method. Okay, let's now see the demo. So here, hopefully the font size is okay. Okay, cool.
Maybe you can close the project view so that we can see code.
Yeah. So this is the SignalStore that we saw in the examples. I mean, it maybe has this is pending flag or something additional. But what I want to show you here is the first part is actually generating signals. So here we defined 2 state properties, and we pass the initial state. Then in with computed as an input argument, we can inspect the type of this property, and you can see that its type is signal that contains array of books, because this is the type, is a book array. We also have here is pending, which is a signal boolean, of course, because the type of this property is boolean. So SignalStore will generate automatically for us these nested signals. It will not go only one level. If we have nested objects in our state, for instance, if I say here st1 like this, let's quickly inspect what we have here. So now we have this property here, but the type is deep signal. So if I say t plus 1, I want to create another computed signal here, and I use computed again. So this deep signal can be used as any other signal, which means that we can return it, for instance, here, result, and add some additional behavior. But deep signal, the properties of this property here will be actually signals that represent nested properties of this object itself. So if we do m.s and inspect the type of m.s, you can see that it's again a deep signal. Why? Because the value of s is again an object. But if we do m.s.t, you can see that the type of t will be a signal number because it's a primitive value. So what we can do here, we can say t plus 1, for instance. All nested signals are created lazily, on demand. So when I request first time this s property here under the hood, the signal for this s will be created, which is great for performance. Also, they are cached. So if I do, I don't know, m.s multiple times in my code base, they will share the same instance of signal. So it will be created only once. Yeah, that's it about this behavior with automatic generation of the signals for the state slices and for the nested state slices as well. This is the way how we can update our state. So we are using a patch state function that accepts a store as a first store instance. If we inspect the store instance here, you can see that it contains all previously defined state slices as well as computed signals. And then as a second argument, we can pass a partial state object. To update our state, we can also pass a partial state updater. So I can say here state, and I want to update the books. So we can say state.books, and then add this book here.
May I have a quick question? So,
yep.
The with method is reducer, the new reducer, right?
No, this is not a Redux pattern. It's closer to...
Taking its place, right? So we don't...
So when we define methods, we usually have two different types of methods. We have updaters that are similar to case reducers, let's say, and we have side effects. So this is an updater actually, because we are updating our state. This is similar, we can say it's similar to case reducer. All right, so what we can do now, I told you that in the beginning that patch state function can accept a sequence of state updaters or partial state objects as REST arguments. So here I can define additional, I can say is pending false if I want, and things like that. And you may be wondering now, why do we need this? Why do we need this functionality to pass, I don't know, n number of different partial states or updaters to update our store if we can do everything at once here? And the reason for that is to be able to create custom and reusable updaters. So what I can do here, I can create a new function. I can name it add or create book, something like this. It will accept the book as an input argument, and as a result, it will return a type of partial state updater. You can see that this partial state updater type is imported from the NgRx signals package. So here we need to define what slice of state this updater will update. It will update only the books array, so we can say here we want to update books, which is type of array of books. Then as a result here, we want to return a function, and we can actually copy this code from here, like this. So now instead of defining updater directly here, what I can do, I can call create book function and pass book as an input argument. I can do the same for isPending. I can say function set pending, or this will be, if we say set pending true, so this will be set pending. And here we actually don't need to return the updater at all. We can directly return the partial state object. We can say return is pending true, like this. And the result, if we want, we can also type it here. We can say is pending boolean. So now here, instead of passing directly the is pending true object, we can say set pending, like this. And what's the advantage of this approach? So we now create reusable updaters. First, they are easy for testing because they are pure functions, right? But also, if, for instance, we have, which is the case in 99% scenarios probably, that we have some loading flag in multiple stores or feature states, and we want to write our state management logic in a dry way. When we define a reusable updaters like this, they can be, for instance, create book can be used in any store that has array of books as a state slice. We don't need to repeat this logic over and over, right? We can use it directly here. The same is for isPending. Okay, the next thing that I want to show you is how we can define side effects. And first, let's go with promises. So for instance, let's say that I want to load all books from the API. So we can say async load books like this. And here, first thing that we need to do is to call patch state, pass the store as a first, and call set pending. So to set loading to true. Or let's delete this one, because we will create a custom feature for this later. Just let's for now use isPending true here like this, or here, let's say isPending true. All right, the next step is to fetch books from the API. So we need to inject the service. The good thing is that with methods factory is executed within the injection context, which means that inside of the factory function body, we can inject our dependencies. So we cannot inject dependencies within methods, but we can inject dependencies here within our methods factory. So what I can do here, there are two options. The first option is to, instead of using this shortcut, I can return this object here, like this, and then here we can say const books service is equal to inject books service like this. So I can use the book service here. This is the first option, and the second option is just a shortcut. So here, as a second argument, I can say books service is equal to inject books service. Now we can use a book service and say const books is equal to await book service dot get all. Get all will return a promise, so we can use async await syntax and then call patch state again, pass the store as a first, and as a second argument we want to replace the book collection with the loaded data and also set isPending to false. Yeah, by the way, we don't need is pending here. It can be removed. It was just an example. All right, so this is the way how we can define a fetching logic, how we can define a method that will load books from the API.
And if I want a different instance of book service, can I do that? Yeah.
What do you mean by that? Different instance?
Like, based on injection token, can I choose different book service?
You can inject here everything you want. So it depends. So if you provide your store at the component level, at the component injector level, then it will be reinstantiated every time one component is created. And it will start looking for the injector tree from the same level as component starts looking to.
Yeah, because normally I'm doing that in providers, and I just can't see the place here to put that in the providers.
Actually, so here we are injecting the service. We are not providing it. And this service is provided in root. If we want, we can provide it somewhere else.
Okay.
But it needs to be provided, of course. It needs to be provided. What can be the next step? So then we need to call these load books. And here we also have another file, books component, and this component uses the bookstore to manage the local state. So a bookstore is provided at the component level. Here we are injecting this bookstore and using in the template. So this is the presentational component. We are just providing inputs here. Here you can see the compilation error. I mean, IDE shows that we have a compilation error, but actually we don't have it because we're using a new model. New model API that was previously mentioned, but we need to wait for the next version of WebStorm to see the proper IntelliSense for this. Anyway, what I wanted to show you. So here, when this component is initialized, we can say we can implement on init, then call ng-on-init, and when our component is initialized, we want to say this.store.load books, right? This is the first option in this case. The second option that we have is to use store lifecycle hooks. So I can go back, I will go back to my bookstore.ts file, and here, as a last feature, I will use with hooks. We saw the first signature of the with hook, so it also sets a factory, and here we have the store, right? The store instance will contain all previously defined state slices, computed signals, and methods. This is the first signature. The second signature is simpler, so if we want to only, for instance, have on init, we don't care for on destroy hook. We can pass the object directly here and define the on init method. We will get the store instance here as an input argument of the on init method. So I can say store.load books like this. So what will happen under the hood? When this component is initialized, the store will be also initialized. Why? Because it's provided at the component level. When the store is initialized, this on-init hook will be triggered and the books will be loaded from the API. And in these simple examples, you can see that using promises is okay. I mean, here you can notice that error handling logic is missing. If we want to handle errors here, we need to go with some imperative approach with try and catch and stuff like that. And in more advanced and more real-world scenarios, we will probably need to take advantage of RxJS API. And instead of using promises, we can still use RxJS to handle side effects. So the idea is to take best from both worlds. To use signals for the state and to use RxJS for handling asynchronous side effects. With NgRx SignalStore to handle asynchronous side effects, there is an API called Rx method. So let's imagine that we have some query and we want to, every time when query value is changed, we want to refetch books from the API. we will try to implement that. So here I will create a new method. I will call it load by query. And I will create it by using Rx method function. This function is imported from the RxJS interop plugin from NgRx signals package. And if you're familiar with NgRx ComponentStore, Rx method is actually ComponentStore.effect. So Rx method will return as a result a method. Obviously, it's a factory function. As an input argument here, we can chain RxJS operators that we want to use. Every time when we called our reactive method, this reactive chain will be executed with a new value. To group several RxJS operators together, we can use pipe function from the RxJS package. So now what we can do here, we can say, okay, let's first do distinct until changed. Then I want to add some debounce time, 300 for instance. And then let's call tap. And I want to patch my state. I want to set is pending to true, like this. The next step will be to use switch map. And here, as an input argument, we should get the query. To specify the type of the reactive method that will be created by using this Rx method function, we need to pass here input generic argument. So in this case, query will be type of string, so we can say that type here is a string. So we will get the query value here. Let's inspect this type quickly. You can see that type of query is string because we said that string type is here. What's the next step? We can say return book service. And in book service, I already created a method called getByQuery that accepts a query as an input argument and returns observable of books. So we can call this method and pass a query as an input argument. The next step is to handle the API response. In case of success, we want to add filtered book collection to our store, to the state of our store. In case of error, we want to, again, set pending to false and, I don't know, display the error. So what we can do here, we can use tap and we can use catch error. So native RxJS operators. But instead of them, we can also use an operator called tap response. This operator was previously part of the ComponentStore package, and now it's part of the NgRx. So we created this package called NgRx operators that contains agnostic RxJS operators that can be used not only with NgRx APIs, but also with other state management solutions or APIs. So we can call tap response here. If in case of success, what I want to do, so here I will receive books. I want to call patch state, pass the store as first, and books, and set is pending to false as a second argument. And then in case of error, first I want to specify the type of my error. So it will be, for instance, message string, like this. And then we'll just patch the state. Let's say store is pending false. Additionally, if we want, of course, we can log this error message, display a notification or something else. It's not really important. So the result of this call will be a method, a function. This function, load by query, can accept a string, so a static value. It can accept a signal or observable. So let's go here. On init, you can see that if we say store.load by query, we have it here. So if you pass a string like this, what will happen if I say NgRx, for instance, this value, NgRx string, will be passed and executed through this reactive chain of RxJS operators. So in this case, books will be filtered by this query here, NgRx. If I call it twice, nothing will happen because we have distinct until change here. I mean twice with the same argument. Another option is to call it with an observable, and if we pass observable as an input argument of this reactive method load by query, this logic here will be re-executed every time when observable emits a new value. And it's very similar with signal. So when we pass a signal as an input argument, this method will be, of course, re-executed every time when signal value changes. In our case, we want to add a new state property here, so I will remove this. This was just an example, and we can remove this from here. And then I will add a new state property, I will call it query. And it will be an empty string initially. So when I define the property here, SignalStore will automatically create, we can inspect here, we will have a query signal string. So what we can do here, we can remove this and say store dot load by query, and then pass store dot query as an input argument. So I'm not executing this signal because I don't want to call this reactive method only once. Instead, what I want to do, I want to call this method, I want to refetch books from the API every time when the value of query signal changes. The next step is to define a method that will update the query value, and we will call this method from the component. So here, we can now remove add book and load books and add update query method. This method will accept a query which is type of string as an input argument, return type will be void, and then we can say patch state store, and we want to update the here like this. So we have the updater, we also have the side effect. Side effect is called here when component is, when this store is initialized, and we want to call this update query method every time when the value of query input changes. So we can go back to the component, books component TS. Here we have this search box component. First, I want to bind the query to be equal to store.query, like this. And every time when the query value is changed, we can call story.update query and pass $event here. So the value that is emitted by this query change emitter. Let's save this and see, yeah, we have some compilation error here, yeah, because we removed this state slice. We need to get rid of this as well. Let's now open the browser and see if it works. So here, this is our simple application. We have a search box and we have a list. When I type something here, Harry, for instance, you can also see the loading flag when it changes, and our list is updated automatically. All right. So what we saw here, we saw how we can define methods, how we can define updaters, how we can define side effects, how we can manage side effects by using promises, and also how we can do it in a more powerful way by using RxJS APIs. And let's now see how we can refactor, how we can improve this store, because I don't like, to be honest, how it looks like.
Move the methods to separate files.
Yeah, let's see. But you may be wondering all the time, why functional approach? Because in Angular we usually create classes. We create stores as classes when we use RxState or ComponentStore, for instance. And I worked a lot with ComponentStore in the last couple of years. And the reason why we ended up with a functional approach for the SignalStore is because we faced a lot of limitations that class-based state management solution provides. The first one is typing. It's not possible to define a dynamic class properties or methods that are strongly typed. In other words, if you use the component store, we pass usually the initial state to the parent constructor when we extend the component store base class. And then what we do, for each component store, we manually create selector for each property, for each state property. And actually what we can do that automatically, as we did for SignalStore. So in SignalStore, we pass the initial state and we automatically get generated signals. The same can be implemented for the component store, but case of ComponentStore, we would have observables, of course, but the problem is typing. We cannot provide type for that dynamic class. It's not possible in TypeScript, unfortunately. The second problem of class-based state management solutions is tree shaking. So unused class methods and properties won't be removed from the final bundle, right? They will be removed only if you're using Google Closure compiler, but the chance for that is probably low. So what happens? We use ComponentStore, we extend the base class, the base ComponentStore class. Then, for instance, we only want to define some updaters, but the effect logic will also end up in the final bundle, because as mentioned here, class methods and properties are not reshakable. Another limitation is extensibility, because multiple inheritance is not supported. I mean, it's possible to do with some mixing approach, but it's not provided out of the box. The next limitation is modularity. If you use ComponentStore and if you try to split selectors, subdaters, and defects into different files, that's possible, but it's not provided out of the box. And that's another not the best development experience possible that ComponentStore has. And let's now see how the extensibility part and modularity part is done by the SignalStore. Let's now talk about custom store features. And one of the probably most common features, most common state slices that almost any feature state that manages some data from the API has is a request status. So with SignalStore, we can create a custom feature. We can call it with request status. I'm using the with prefix just to be in accordance with the base features that we have for the SignalStore. To create a custom feature, we can use the SignalStore feature function. And this function has the same API as the same signature as SignalStore, actually, because it accepts a sequence of base features or other custom features as arguments. So for instance, in case of request status, I want to add a state slice called request status, and it can be idle, pending, fulfilled, or error. Then I will also want to add some computed properties. I want to add is pending, is fulfilled, and error. So maybe so far you manage your request status state but by having, I don't know, loading boolean, loaded boolean, and error, but actually these different properties, we can merge them together into a single property. Why? Because they exclude each other. When we are in a loading or pending state, we cannot be in a fulfilled or error state in the same time, right? So we can manage the entire request status with a single property, and then define computed properties for pending, fulfilled, error, or loading, loaded, and error. I mean, the naming is up to you. And then if we go back to the SignalStore that was previously used, where we had this is pending property, we can remove it and we can use this with request status custom feature that we just created. Under the hood, with request status feature will add the things that we specified there, if you remember. We added a request status state slice, and we added these computed properties for pending, fulfilled, and error status. So now our bookstore will have all these properties. Then we can define a custom updaters, set pending, set fulfilled, and set error for the request status feature. And instead of defining, updating the state of the SignalStore like this, we can use these reusable updaters. I mean, in case of request status, it's not a big difference, of course. It's maybe just an overhead because we have only a single property, but it can bring a significant benefit when we manage some CRUD operations, which we will see later. And this is actually the next topic, and the last topic for today, entities. So in addition to RxJS interoperability plugin, SignalStore also provides this entities plugin. So previously we managed the books collection by defining array. Instead of doing this, we can replace with state this part with another feature from entities plugin called with entities. What will with entities do under the hood? So by the way, with entities is also created by using a SignalStore feature function. So it will add these two state properties. It will add entity dictionary and array of IDs, very similar to the NgRx entity if you used it previously. And it will also add array of entities as a computed signal to the store that uses this custom feature. And then, in addition to with entities feature, entities plugin also provides custom updaters that we can use for CRUD operations. One of them is add entity. And others are, we have remove entities, update all entities, set all entities. So it covers all the cases that all the NgRx entity package covers to manage all the CRUD operations. But you can notice one difference here, actually. You can see that with NgRx entity, if you remember, we created entity adapter, and then from entity adapter, we used the methods. But here, these are standalone functions. Do you have idea why? What's the main reason for this?
Tree shakeability?
Yeah, exactly. So the first reason is tree shakeability, and the second reason is the signature of the patch state, actually. Here we come to another reason why patch state accepts a sequence of updaters as argument. So now we can use add entity, we can create some custom updaters and use them together in a single patch state call to update our state in a single transaction, let's say. Yeah, as I mentioned, they are standalone functions. Let's now quickly see, let's now try to refactor the bookstore to use request status feature and entities. And yeah, we are coming to the end. So what I want to do here, and you can now see how productive we can feel by using a custom feature. So we don't need these total books and free books. I will remove this one. Here we will keep only a query like this. Then I will add with entities because I want to manage my books collection by using this entities feature. Here, as a generic argument, I need to specify what's the type of my entity. The next step is to use with request status, and by the way, I just copied the code that you saw in the slides, this with request status function that is created by using SignalStore feature. So we can now use this with request status in any store, and in every store that uses this with request status feature will contain this state slice and these computed properties. So if we go back here and say with request status like this, and inspect, for instance, the type of our store, you can now see that it contains the entity map, IDs, it contains query, it contains request status. So all these state properties or computed signals are added by using these two features. All right. So what would be the next step? So now here, instead of is pending true, of course, we can say set pending and import set pending updater from the request status feature. And here, I want to use set all entities. This is a custom updaters from the entities plugin. It's very similar to the entity adapter.set also. It will just replace the collection. And here we'll pass books array as an argument, and then here as a second argument we can pass set pending. So we can now see the benefit of having the ability to pass a sequence of partial states or updaters. We can combine them together, but without need to use patch state multiple times. We can do everything in a single call. Here, instead of set pending false, I will say set error and pass error.message. Like this. Let's save this. We should have a compilation error, yeah, here, because we don't have a book state slice anymore, but instead we have entities. All right. Let's save this. We have no compilation errors anymore. Let's quickly inspect. It should work the same as before. So yeah, we can see the loading. Yeah, now we are stuck in the loading state. Let's see what can be the reason. Yeah, here instead of set pending, we need to say set fulfilled or set loaded, however we want to call it. when we receive the API response. So now it's fine. Yeah, it works as expected. Yeah, let's go back to the presentation. I also wanted to share this with you. This is the screenshot from today. NgRx Signals package reached the milestone of 15K weekly downloads. It's currently the fastest growing state management solution in Angular. And yeah, if you want to follow NgRx team, there is official NgRx Twitter account. We also have a LinkedIn, a company page, Discord server. You can join Discord server. We have a lot of different channels where you can ask questions, or you can also help other people if they have any questions. This is also a great way to contribute to the community. We have official docs, ngrx.io, and for more info about SignalStore and NgRx Signals package in general, you can go here and find there are a lot of different pages, different examples, for instance, for the custom store features and all other things. Yeah, this is a new thing, workshops. So from the beginning of this year, we started conducting workshops. Brandon Roberts, Alex Sukrushko, and me. So if you're interested, we are conducting a 3-day-long workshop. We are covering the global NgRx store as well as a Signal store in this workshop. And yeah, if you're interested, if you want to take a look at the source code, how Signal Store is implemented, or if you want to contribute, you can visit our GitHub page. Before we end up for today, I just want to show you one more thing, namely on 24th May this year, we are organizing an Angular conference in Belgrade. We have a lot of amazing speakers from Angular team, from NgRx, NX team. Michael will be also there. And if you're interested in attending, I will share with you. So this is the discount code for 10%. For the ticket.
Is the CFP still open?
Sorry?
CFP still open?
No, it's closed last week. But we still need to announce other speakers. That's it. Thank you very much for your attention.